Today we're going to be talking about stoichiometry and doing some basic problems. We'll start here with some basic steps. If you want to copy these steps down, that might be helpful, and because we'll be following those in these problems. Also, these conversions are very handy conversions. These are almost all the conversions you'll need in chemistry when it comes to stoichiometry, with the exception of 22.4 liters in a mole for gases at standard temperature and pressure. This chart is also kind of handy here if you want to copy it down. It goes from what you're giving in a problem to what you need to get, and it tells you how to get there. So this is sort of your roadmap from getting from certain given information to what they're asking for. All right, let's get started. We'll start with cobalt 2 chloride. First, you need to be able to write an equation. You'll need to know that cobalt 2 means that it has a +2 charge. Chlorine has a negative, and so when you crisscross, you'll be able to write that formula down. It reacts with fluorine. Fluorine is one of your Brinkelhoffs, so it's going to have a diatomic compound. It'll be a diatomic compound, so don't forget that. It's in a single replacement reaction to produce cobalt 2 fluoride. So again, cobalt 2, and then fluorine has a -1. You'll need a periodic table, and you'll notice that it looks like this. And chlorine gas. Of course, chlorine is one of your Brinkelhoffs, so you will write it as a diatomic element. The key here is to balance your equations. So you've got a cobalt on each side, 2 chlorines on each side, and 2 fluorines, so it's balanced. Let's move on to some stoichiometry. They're asking for grams of fluorine. Okay, so they want to know how many grams of fluorine are required to produce 290.8 grams of cobalt 2 fluoride. So you have 290.8 grams of this. Always start with what you're given, 298 grams of cobalt fluoride. It helps to write both the units and which compound you're talking about in the formula, so you don't get yourself mixed up here. All right, so in order to get rid of grams of cobalt fluoride, you need to go ahead and put it down here. You know you're going to have to get rid of it. And the only relationship that I have with grams is to go with moles, which we'll use the periodic table to determine the entire molar mass of cobalt and fluoride. If you look at the periodic table, you look at cobalt is 58.933. Each fluorine is 18.998. You need 2 of them. So when you add them all up, you need 96.90 grams. Now, you might get a little bit more decimal places here, but since there's only 4 sig figs in your given information, you don't really need to go any more detailed than that because your answer can only have 4 sig figs. All right, moving along. We're going to go from moles of cobalt fluoride to something else. Where are we going? Let's go back to our problem. Our problem says that we're going to fluorine, so let's go to moles of fluorine. Now, we know that from our equation, we look at our coefficients in our equation, and the coefficients tell us we happen to have 1 mole of cobalt fluoride in this relationship for every 1 mole of fluorine. It doesn't always work like that, but in this case it does. So now we need to go from moles of fluorine to, what are we looking for? Grams of fluorine. So let's go and look at our periodic table, and our fluorine again was 18.998. But you actually don't just have fluorine, you have fluorine gas. Even though the problem says the word fluorine, they're referring to the fluorine that's in the equation, which is fluorine gas. So you'll multiply it by 2, and you get 38.00. Again, if you multiply the numerators, divide by the denominators, you will get a final answer of 114.0 grams of fluorine. And that is your answer. Okay. Let's move on to another example. As you can see, there's a balanced equation already here, and we're going to scoot this down. All right, so we have strontium chloride and sulfuric acid making hydrochloric acid and strontium sulfate. There's 1 strontium here, 1 here, 2 chlorines, which means I need to have 2 chlorines here. Always use coefficients, not subscripts, to balance. two hydrogens, one sulfate, one sulfate. We are now balanced. Okay, they're looking for the mass of strontium chloride. So here we're looking for how many grams of this. That reacts with 300 grams of sulfuric acid. We've got 300 grams of sulfuric acid. I always like to write the given and wanted information underneath the equation because it keeps me visually in track with what I'm doing and where I'm going. Start with what we're given, 300 grams of sulfuric acid. All right, and we know for sure we're going to need grams of sulfuric acid down here, and the only relationship we have is grams per mole by using the periodic table of sulfuric acid. Okay, so if you look, you'll need to multiply 1.008, which is hydrogens, times 2. Then you'll need to add sulfur, which is 32.066, and then 4 oxygens, so it's about 16 times 4. When you add them all together, you get 98 grams of sulfuric acid. Okay, let's cancel our units so that we're keeping track of what we're doing. Now I'm going to go from moles of sulfuric acid, and let's look. Where am I going? I'm going to strontium chloride. So I can look at my strontium chloride. Now if you look at your relationship up here in your equation, you'll notice that for each 1 mole of strontium chloride, you actually just have 1 mole of sulfuric acid. Okay, that came from our formula up there, our reaction. Okay, now I'm going to go from moles of strontium chloride, and there's one of those, and I want to go to grams. Mass is in grams, typically in chemistry. Okay, now the mass of strontium chloride, you would add the mass of strontium, which is 87.62, and then add the mass of chlorine, which is 35.453, and altogether you get 158.5 grams in each mole. Always go back and cross these out to keep track of where you are. When you multiply all the numerators and divide by your denominators, you get 485.2 grams of strontium chloride. Great job. Okay, now let's move on to the next one. The next one talks about solid iron, and it's iron 2 oxide. So iron 3 oxide refers, this 3 in parentheses refers to its oxidation number. So you have iron 3, and oxide refers to oxygen, which has a -2. Then we'll use our crisscross method. So when you write it, it kind of looks funny because it's Fe2O3, but it's actually an iron 3 oxide. It reacts with hydrogen gas. Again, hydrogen is one of your Brinkelhoff elements, so it's going to be a diatomic to form iron. And since they said iron, we're talking about just iron solid and water. All right, now let's go back and balance this. Let's see, we need 2 irons over here, so 2 irons here. We have 3 oxygens here, so let's put 3 here, which means we have 6 hydrogens, which means we need 6 hydrogens. Now we're balanced. All right, how many grams of iron are produced when 450 grams of iron 3 oxide are reacted? So we have 450 grams of this, and we want to know how many grams of iron. So we're trying to get to this. This is our goal. Okay, let's start with what we were given, 450 grams of iron 3 oxide. Okay, and that's automatically going to be our denominator because we want to be able to cancel that. So we want to go from grams. The only thing we can do is go to moles of iron 3 oxide. When you add up 2 irons and 3 oxygens, you'll see that you get 159.7 grams in 1 mole. Let's cancel our units. Okay. Now we're going to go from moles of iron 3 oxide to, where are we going? Just iron. Moles of iron. If you look at your formula, 1 mole of this compound will produce 2 moles of iron. So that helps us out. Now we're not quite there yet. It didn't ask for moles, so we're going to go from moles of iron to grams of iron. Okay, and this is in 1 mole. So how many grams are in a mole of iron? 55.845. Okay. Now, when you multiply your numerators, divide by your denominators, you will get 314 grams of iron. But if you'll look, there's only 2 sig figs here, so I can only give 2 sig figs here. So we're going to go with 310 grams of iron because we can only have 2 significant digits. Let's look. There's another question here. How many grams of water? And since to make life easier, I'm just going to erase all this stuff right here. Kind of clear everything up since we're on a new part. Okay. Okay. All right. So we had iron 2, or iron 3, excuse me. Nope, I was right to begin with. Okay. Fe2O3. Okay, and there was a 1 in front of there. How many grams of water, so I'm looking for grams of water, will be produced when this many moles of hydrogen gas? So you have 0.155 moles of hydrogen. Okay, so start with what you're given. And again, we're looking at the equation. There's no single hydrogen all by itself in the equation, so you have to use the diatomic element. All right, so moles of hydrogen, and we're going to grams of water. Well, we can't go from moles of hydrogen to grams of water, but we can go from moles of hydrogen to moles of water by looking at the stoichiometric relationship in the equation. Notice in the equation it has 3 moles of hydrogen will make 3 moles of water. Okay? All right. Now we're going to go and continue by going from moles of water to grams of water. Notice in this one we started out with moles, so we didn't need the molecular mass of hydrogen. We just went with what we had, which was moles, and then we used our relationship. Okay, grams of water. You have 2 hydrogens and 1 oxygen, so you're going to have about 2 here and about 16 there. So when you add them up, there's going to be about 18 grams per mole. And then when you do your math, you will get 0.279 grams of water. Now, your calculator is going to give you more information, but again, you can only go back to 3 significant digits. Good luck, and I'm sure you'll do great.